Hey guys, welcome to CodeChef's YouTube channel. The problem that we're going to discuss today is make that array. The problem appeared in Starters 13 of September 21 and has a difficulty level of easy. There are no prerequisites to solve this problem. The problem statement goes as follows. Chef is given two arrays A and B, each having n elements. In one move, Chef can choose an index I and get the score of AI minus AI plus 1, that is subtracting the next number from the current number, okay, and then swap these two elements. So basically in one move, Chef can choose two consecutive elements in the array, swap them, and at the same time get a score of AI minus AI plus 1. Okay, so for example, if Chef has the array 10, 7, 5 and he chooses the index 1, so the first two elements will be swapped. So the resulting array will be 7, 10, 5, and at the same time the score added will be 3 points because 10 minus 7 is 3. So this is the move that the Chef can do on the array. Okay, so what is the target of our question? The target is that we have to help Chef in finding the maximum number of points he can get while converting the array A into array B. It means that we have to swap the elements by doing some number of moves, possibly 0, in such a way that the score is maximized. Okay, and note, it is always guaranteed that the input is such that there exists a sequence of moves by which the array A will be converted into array B. So the elements in both the arrays are same. Okay, they may be permuted, but they are the same elements. So you don't have to worry about that. There exists some sequence of moves by which you can convert A into B. Just that we have to maximize the number of points that Chef can get. So this is pretty much the question. The question is pretty easy. The statement is easy to understand. Now let's understand more in the solution approach. The solution approach goes as follows. We will understand the question and its solution with the help of an example. So we have two arrays with us, A and B, and they have pretty much the same elements, but the ordering is different. So we have to do some operations on array A such that it is converted to B, and at the same time the score is maximized. Okay, so remember that in each move you can choose two consecutive elements, that is one element is AI, another element is AI plus 1, and then swap them, and at the same time you get the score of AI minus AI plus 1, that is the current element minus the next element. That score is added to your current score. So that is the question. Now the thing to notice over here is that although the move gives you the power to swap consecutive elements, you can use multiple of these moves to swap any two elements of your choice. Say, for example, you want to swap this 2 with this 6. Okay, so if you want to swap these two elements, you can do that by doing consecutive swaps with consecutive elements, and finally 2 will come over here and 6 will come over here. The good thing to notice is that because of the nature of these swaps and the score that we are getting, it is definite that the score is only affected by these elements. Okay, the element 2 and the element 6. These middle elements 2, 4 and 6, they do not affect the score at all because in the end they are present in the same position, right? So this will be more clear if you take just a small example of two elements. Okay, because whatever moves you do, they're exactly reversible. So what happens is that, let's say you have two elements. Okay, the element is 2 and 3. You decide to swap these two elements consecutive. Okay, so it will become 3 comma 2. And how much score did you get? Your score has now become 2 minus 3, that is minus 1. What if you again decide to swap them? If you again decide to swap them, they will become 2 comma 3 and you will get a score of plus 1. So minus 1 plus 1 will become eventually 0. So if the state is same, the score is same for the elements. Similarly, you can extend this logic for bigger arrays and elements present at different positions, not just consecutive, and you will see that swapping these two elements, the score is dependent only on those individual elements who are getting swapped. Okay, So this gives us the room for a lot of opportunity. So I'm going to be telling you a method that I personally use for such kind of questions. So that method goes something like this. So the move is given to me. I know the move and I also know that I have to redistribute the elements or repermute the elements such that it is finally equal to this array. Okay. So I know that there are two twos present over here and finally I want two twos over here. So their positions should be changed. But which two should be present? So which index should be paired with which index? That is something which I don't know for now. Because if I try calculating all such pairs and try mapping them, it will be a mess because now the question of twos will be solved. Okay, if I do those swaps, twos will be solved, but then we will have a new position wherein 4 and 6 will land over here and again you will have to redistribute them and so on in bigger cases. So to better solve this problem, what I do is that I imagine an imaginary position. Okay, so I take an imaginary position over here before all these elements. This is position 0. Okay, let's call this position 0. So I imagine a position 0. Okay, and I bring all my elements over there. So my elements 2, 2, 4, 6, 6 will come over here. 2, 2, 4, 6 and 6 are over here. So what is the score that I get after I bring all these elements over here? Because we saw that the nature of moves is of swapping the current elements. Basically, whenever an element goes to the right, its score is added. Okay, that is plus AI. And whenever an element comes to the left, one place left, its score is subtracted. That is minus AI plus 1. So what I can see over here is if I bring all the elements to position 0, now I can see that all these positions are empty with me and these are empty. So I'll just draw them as empty seats. Okay. And what is my current score? Current score is basically every element came from its original position to position 0. So whatever is the length between position 0 and that position, negative times of that into the value. So that will be the score. So for example, initially it was 2 over here. So 2 came from here to position 0. So my score will be minus 2. Similarly, there was another 2 I think over here. So we have one more minus 2 and so on. Okay, so what will be the current score right now? If I draw the initial array was 2, 2, 4, 6, 6. So we have minus 2, then we have minus 2 into 2. So we have minus 2, minus 4, then we have minus 12. We also have 6 has come 4 positions, 1, 2, 3, 4. So minus 24 and also we have minus 30. Okay, so my current score is addition of all these numbers. You can add them for yourself. I'm not going to add them right now because I'm focusing on the final answer. So once all the elements are present in this imaginary position, from here I will redistribute the elements. So now I know that my final target is that I want a 4 over here. So what I will do, I will pick up a 4 from here and put it over here. And what is the score needed? Remember, whenever an element goes to the right, one position right, its score is added, right? So what will be my score? My score change will be plus 4 because from position 0 to position 1 there is the length is 1 and the value is 4. So I do a plus 4 in my score. Then I do a plus 12 in my score because a 6 will go from here to here because it is needed. Finally, its position should be here. So plus 12, then 2 into 3, then 2 into 4, and 6 into 5. So what is this? This is plus 6 over here, plus 8, and plus 30. Right. So these two get cancelled with each other. Plus 12 and minus 12 get cancelled with each other. Minus 6 and plus 6 get cancelled with each other. And finally, we have minus 24 plus 12, that is minus 12. So our final score is minus 12. So, but wait, the question asked us that we have to maximize this score. So if you take many examples and do these kind of swaps with them, you will understand that actually in this game there's only one score possible. There is no maximum score and minimum score because the positions of the elements are finally fixed. 4 should finally come over here, 6 should finally come over here, similarly for all other elements. So there is nothing you can do about this score. There is only one possible score, and that is the maximum possible score. So for this example, where the initial array A, I will write it over here again. Initial A was 22466. Okay, this was the initial one, and your target array was this. For this example, the answer comes out to be -12. What was the intuition and the trick that I used for this question? And you can use this trick for many such questions which involves changing the positions of elements in a particular array. So I imagined the position at position 0. I brought all the elements over there, and from there I redistributed the elements. So it reduces a lot of things for me. I don't have to worry which element should be paired with which elements. Okay, I just deduced that from the given operation. What it means is that whenever an element goes to the right, its value is added. Whenever an element goes left by one position, its value is subtracted. So that's it. That's with my solution. So this can be now easily coded, because if you basically see what is the score at the end, the score is basically summation of bi into I minus ai into I. Why? Because initially we brought all the positions in array A to position 0. In that, because every element moved to the left, the score was subtracted, and finally we redistributed. In that, the score was added back. So this is pretty much our solution: summation of bi into I minus summation of ai into I. So that can be easily coded. As you can see over here, I have taken the input for number of test cases. After that, I take the input for n. There are two variables, capital A and capital B. I run a for loop, take the input for the A array, and calculate the value of I into A of I. Because I don't really need the value of A of I later on, I just store it in a temporary variable. So A plus equals to I, and you can assume this num is basically A of I. Similarly, I run again a for loop for the B array. I take its input but store it in a temporary variable for each index and calculate the value of B. So B plus equals to I into num, which is basically I into B of I. And finally, I just output B minus A. So if you see this in my code, this whole term, summation Bi into I, is actually capital B, and this is capital A. So that is what I have done, and that is only one possible score. So there is no maximum possible score. Actually, there is only one possible score. So that's what I output after redistributing the elements, and that's it. That completes our solution. So I hope you guys understood my solution approach and the idea of how I used the imaginary position to redistribute the elements. If you have any doubts, you can ask them in the comments below. I'll try to answer as much as I can.